For those that don't know, my name is Aaron Wilson. I am an atmospheric scientist from The Ohio State University, and again have a joint appointment between the Bird Polar and Climate Research Center and OSU Extension. My expertise is in weather, applied climatology and climate change, and work closely with the State Climate Office at The Ohio State University. One of the things that I think, or at least I'm hoping you get from today's presentation, is how personal weather and, in fact, climate change are. It's a personal story for all of us, and the more personal it becomes, the more of a heart issue it becomes. You know, I can show you a lot of data, and I'm going to today. I'm going to show you data. But really, when it comes down to it, this is a heart issue. It's impacting all of us, and it's something to keep in mind as we move forward. So I'm going to talk today about the agricultural face of climate change, changing climate here in Ohio. And I thought I would start out, if this will work for me, I thought I would start out with this couple of comments here. The degradation of critical soil and water resources will expand as extreme precipitation events increase across agricultural landscapes. Sustainable crop production is threatened by excessive runoff, leaching, and flooding, which will result in soil erosion, degraded water quality in lakes and streams, and damage to rural community infrastructure. These predicted impacts are already happening today. Thunderstorms are much heavier, droughts often last longer, false springs threaten orchards, and abnormal weather events and climatic conditions are forcing farmers to adapt to challenges that are affecting their productivity and waterways. Now, this is a summary of statements made in the fourth National Climate Assessment. This assessment involved over 300 experts in many fields, federal agencies, Review Board, and the National Academy of Science. And these are the statements being made about what's happening today in agriculture and what we're expecting to happen as we move forward. So we don't have to look very far to see these impacts already in progress, right? We can just assess this past year. We can just look at what's happened this past year or the year before that. If we think about, and these are probably still fresh scars for many of you, but I think it's good to start here. You know, late planted small grains in the fall, followed by some winter injury, persistent water and water damage. It's left us with a lot of lack of forages across the state due to poor stands and heaving conditions. Late planting or no planting of soybean and corn this spring. Just couldn't get out in the field when it rains 26 days in the month of May, right? Impacts on fruits and vegetables. Impacts to strawberries, impacts on peaches. Disruption of the cycle. When am I going to plant? When can I spray? And eventually we'll have these harvesting decisions we have to make as well, right? And difficult crop and field management questions that involve much more than weather, much more than the changes that we've seen in climate, but certainly climate is an impact factor there, right? So assessing this past year, and we look at the conditions that we've seen, yeah, we can think of it as just 1 year, but how was 2018 and how was 2011 and some of these other things that we're seeing? And so what I'm going to do is kind of show the data that supports that these changes are happening, and that, you know, for better or worse, we have to respond to those. We have to respond to these changes. So we can summarize 2018 this way, and hopefully those in the back can see. 2018, last year, was the 19th warmest for the state. Now, our modern records go back to 1895. So it wasn't, you know, top 10 warmest in 2018. We certainly had warm periods or cooler periods, but it was the 19th warmest. But more importantly, it was the third wettest on record, 2018. The figure on the right shows precipitation. Generally across northwest Ohio, we had 30 to 40 inches, 40 to 45 inches last year, 40 to 50, sorry, 50 to 60 inches along basically I-71, and then 60 to 80 inches of rainfall in the southeast and southern parts of the state. We had stations with more than 75 inches of rain just east of Cincinnati. So that helped the state push it to the third wettest. And you can see this is just compared to average, the percent normal here. So generally 1.5 to 2 times our normal rainfall for an entire year. So if you look at the top 10 ranked precipitation years for Ohio, these are the top 10, okay? 2011, calendar year for Ohio was ranked as the highest. We averaged about 55, 56 inches of rainfall. But if you look closely, the top 10 since 1895, 5 of them have occurred since 2003. Okay? If you go since 1990, you can add 2 more. So 7 of the top 10 wettest years have happened since 1990. Now, does that necessarily mean that more rain is bad? No. In fact, we've seen yields up and up, right, since the 2012 drought. But certainly this is a challenge, and it's certainly a challenge to farmers. We can think about last season's growing season. You know, we hear a lot about that our freezes are extending a little later, freezes are happening, they stop in the spring a little bit sooner. And sure enough, if you look at last year, and that's what the map on the left shows, it's just generally the growing season length between the last 32-degree temperature in the spring, first 32 in the fall. It was about 10 days longer than the long-term median for Ohio. And that fits what we've seen in terms of the overall trends since the mid-20th century here across the Midwest. 9 to 10 more days where we have frost-free conditions. Does that mean that we're farming? We've got 10 more days to farm? I don't know. Does it? So we start breaking down 2018 a little bit more, and we can recall, if you can, this is a long time ago, I realize that. We go back to April of last year. We had the 9th coldest April on record. Okay? What happened in May? Ohio had the warmest May on record, again, going back to 1895. So we're talking extreme month-to-month variability. We could probably say last May really saved the season, right? I mean, as hard as April was, May was beautiful, dust was flying, a lot of things were getting done. But it did stay a little bit cooler and wetter than average to about mid-May across northern Ohio, and certainly that brought on some of problems up there as well. Then we get into summer, and I ask the question, how can it be so dry when it's so wet? Right? This idea, June 2018 was the 4th warmest on record. And the summer was the 17th warmest. These aren't astronomical records here, but certainly they're on the high end of things. And we really dried out, right? The warmth was driven by these overnight lows. Daytime highs may not be getting very, much above average, but our nighttime staying in the 70s and even 80s in some places. Accelerated growing degree days, right? Could be good. We still had some problems with vegetables across the north struggling to catch up. And we had some moderate drought conditions across the northwest portion here, Ottawa, Lucas Wood, Fulton, Sandusky counties here. Some drought conditions. In a year, 3rd wettest. Right? That's kind of phenomenal to think about. And then I would say our problems really began for this year in the fall, right? We had another crazy fall, another extreme variability. This was the precipitation that fell across for September, October, November. Some places seeing anywhere from 15 to 25 inches of rainfall for those 3 months. Again, that's pushing almost 2 times normal. September, October, November were the 3rd wettest since 1895. September was the 2nd wettest, and of course we had a couple of tropical systems that really drove that variability. But we also had the big flip again in the temperatures where October, maybe we can have an okay harvest. And then we had a cold November, right? And really shut folks down, cold and wet, and many were struggling throughout the winter. So we're heading out of fall, and we're heading into winter, and as a climatologist, I'm looking at the El Nino predictions. What does El Nino mean for Ohio most of the time during the winter? Drier than average. There's some hope, right? We're going to dry out a bit. Did we get any relief in winter? Nope. Winter 2019 was the 11th wettest on record for Ohio. Again, about 150 to 200% of normal, and that's what the graph here is on the right. A lot of that was focused across the southern portion of the state. We also had some intense cold to deal with. How can we have these intense, quote-unquote, polar vortex episodes, right, where we get this very cold air coming down to the Arctic, with frequent frost-free cycles, right? So nights where we would go from the sub-zero all the way up to 40 degrees the following day, right? So a lot of that frost-free happening, and that led to some winter injury because things were also very wet. And then we push into spring, and it was really rinse and repeat over and over. Except now we were targeting, if we look at the state March through May, it's not phenomenal. 36th warmest, 32nd wettest, still in the top tier. The east and the south actually fared a little bit better than our west central and north central Northwest friends, right? So West Central and Northwest Ohio rank 7th and 3rd wettest on record, respectively. And these are some crazy numbers, right? We look at Coco Ross, which is a citizen science-driven observers, reporting over 20, and I think it was Jeff, but reporting over 20 inches of precipitation between March 1st and May 31st. That's over half of the annual total in just 3 months. Okay? Multiple observers in excess of 15 inches, probably many of you in the room. 20 to 26 days of rain in May. So a different May than we had last year. So it's given the idea that May turn out to be the month that really makes or breaks us, right? Because if we've got cold, wet Aprils, as you'll see in a second, if our Mays are rough like they are this year, it could lead to some problems. And Gary mentioned suitable field days. So there were only 7 suitable field days in the month of May for the state of Ohio, total, right? So it's hard to get out there. And I know this is a little bit a downer, right? But it's making the connections in the dots. So I think you all agree it's been a very wet year. What you're seeing here are the state rankings for June 2018 through May 2019. So that 12-month June to May period. All the dark greens you see here are the wettest on record for these states. And it's not just Ohio. I mean, it's all the Mid-Atlantic, it's the Great Plains, and a lot of that is what continually kept storm systems moving across the region this spring. And on the right-hand side, you can see the worst of it as far as the year climatology goes is across southern Ohio. And of course, we got through June, and the July through June period said, hey, hold my beverage of choice. We're going to break it again. Wettest 12-month period on record for Ohio, Indiana, Kentucky, Mid-Atlantic, right? Very, very wet conditions. And of course, that has consequences, right? Has consequences that many felt in this room. So we can look at, for instance, this is an animation of the calculated soil moisture ranking. So how wet is the soil column? And it's going to go from August through June here. It'll replay, actually July through June. And you can see that once we got wet, we've stayed persistently wet. The green, the dark green, that's the 99th percentile. So if you compare all the years that are in this data set, it's the top 1%, right, across a large portion of that area. Well, that water has to go somewhere, right? And it's going to run off. And obviously, if you can see the picture here, this is the Maumee River in northwest Ohio, and this is the station at Waterville. And the graph that you see on the bottom is the cumulative volume flowing through the gauge there at Maumee River. The red curve is 2019. 2 other high years were 1950 and 2008, and this record goes back to 1899. So the amount of volume, the water, cumulative water between April and May sent 2019 to the highest on record. So a lot of that water, right, it's got to go, it's got to flow off, and that's what happened. And of course, all the images that have been playing throughout the day, these poor forage stands coming out of winter and heaving, a lot of water in the fields, a lot of weeds. How many have turned butterweed into a cash crop yet? Nobody took advantage of that this year? You know, so it's very challenging. So obviously what I've been talking about here is what? The weather, right? This is the weather. These are things that we have to deal with on these scales. And I know for many of you that have seen me give this talk, I've been using this slide for more than 2 years, and I think I'll use it until I die, okay? Is to really break down the differences between weather and climate. Weather being those fast-paced changes that we see, those day-to-day variations. We got up this morning, a nice temperature inversions. Come talk to me about those afterward if you have a question, right? And then we're going to warm up very rapidly this afternoon. We're going to go up 20, 25 degrees, and then we're going to cool off a little bit tonight, right? That's the typical thing that happens. But all of that is not happening, you know, there are patterns to those that sometimes are undetectable as we're living in them. If you pull out, and this is what this is a series of satellite images stitched across the surface of the Earth showing storm systems or weather, changes in temperature and winds that are occurring. You start to pick up patterns when you look at it from a broad scale, right? You can see along the equator, moving opposite of north and south, you see these fast swirls of storms, right? All of that weather over time create weather patterns. And then over time, those weather patterns establish a climate, a long-term average of those weather conditions across the region. We know that most of our weather moves west to east across this country, right? up here. That creates a certain weather pattern. Those weather patterns are essentially our long-term climate. But how does that differ then with climate? Climate's the long-term average. So I often ask people to guess what this picture is down here, and zebra is usually the favorite answer. Many of you have seen this, but I'm going to show it again because I love it. Right? You've got to, it's a little talking, I'm going to talk over him here. So you see a dog walking with the dog walker. Now that dog is driven by some natural tendencies, right? If it's hungry, sees a McDonald's wrapper, I'm gonna get that. Really got to use the potty. There's a fire hydrant. Oh, look, there's a good-looking dog down here. At any one moment, that dog could be moving in the opposite direction of the dog walker. Okay, so but generally they're going to be in this area here in just a couple of minutes, and we base that on what we're seeing here with the dog walker, the evidence of this dog walker. Even though the dog moves back and forth, we see the direction that the dog walker is taking. Okay, this is a metaphor you can use for weather and climate. Dog being the weather, the variation back and forth, and the dog walker being the climate. They're marching together, but at any one time, they can be peaks and valleys in that weather. And that's just a metaphor that you can use for the relationship between weather and climate. And it's an important distinction because, we're affected day to day with the weather. And sometimes it's hard to think about those longer term changes that we're seeing. Of course, we've been observing the environment and observing our temperatures for a very long time. Again, since the late 1880s, temperature on the ground, radiosondes, these are balloons launched by the National Weather Service, sea surface temperatures, and a ton of satellite data since the 60s and 70s that have been giving us information about changes here on Earth. And what have they shown us? Well, the graph on the left shows you the global temperature changes for land and ocean from annual temperatures since 1880 to 2018. Okay, and that's compared with the 20th century average here. So you can see 1880s and the early 1900s were cooler than the 20th century average, kind of ups and downs in the middle part of the century, and the strong warming that we've seen since the 1970s. So 2018 ranks globally as the fourth warmest on record since 1880. More astonishing is 9 out of the top 10 warmest years for our globe have occurred since 2005. Okay? And this is what it looks like spatially. If you were to take those anomalies across the surface, going back to the late 1800s, you see areas of blue and areas of red, indicating cooler or warmer than average. But this whole tone change in the map here, showing the warming conditions, especially across the Arctic and Antarctica, but also in areas in between. Most of these areas covered by warming. Now, the warming has more effects than just increasing our temperature. At the Bird Center, we study a lot about changing ice, and ice, when it melts, is provocative. It disappears. That water flows off into the ocean. It increases sea level, right? But at the end of the day, when we come back to our homes, right, do we remember the ice melting? If it's not on the news or in something we're reading, we don't, right? What's happening here? So it's about making that personal connection and the connection between what's happening in Greenland and Antarctica with that ice and the sea level changes that are taking place across the eastern seaboard, right? We're increasing our temperatures, but we're also increasing the water vapor in the atmosphere. And that has important implications for things that are happening here in Ohio. So we can look at global evidence. We can see glaciers melting. Again, it's provocative. It changes very rapidly. We can see that. We know that places along the East Coast, this is Miami, but New Jersey and other places are seeing sunny day flooding, right? High tide comes in during the day, inundated water into downtown because sea level is changing. So this is important. It's an important thing that I like to stress is how personal a changing climate is, how personal the weather is. And it's different as you go across the country. If you look at parts out west, you hear a lot about wildfires. Alaska right now is just in flames, right? You hear about those changes. That's their face of climate change. That's what they're seeing. If you go to the southeastern U.S., we know there's evidence of increasing intensity of the strongest hurricanes. How do we build resilience along the East Coast? That's their question, right? What is our question? Our question is, how are we going to maintain profitability and sustainability in ag when we're dealing with 2, 3, 4-inch rainfall rates in an hour? And those are increasing in number, increasing in spatial coverage. That's our question. That's our face. So climate change is really a threat multiplier. It makes what you do harder to do it. Would you agree? So we can break down this a little bit more, and I know I've shown these in the past, but if you look at the temperature changes across the United States, and again, this is from the National Climate Assessment, more than 95% of the land surface has demonstrated an increase in annual average temperature. Now we can do this a couple different ways. We can just draw that line like the climate walker, and we get a 1.8 degree Fahrenheit change over that period. We can also take the last 30 years and subtract the first half of the 20th century to be more conservative, and you get 1.2. And hopefully you're saying, okay, 1.2, 1.8 degrees, that's nothing, right? You just said that we get 20-degree changes in the morning. You're right. That's the difference between weather and climate. That's a change in the patterns. For a 1 degree, 2 degree change is very significant. It represents added heat across a large portion of the country. And our winters are warming twice as fast as our summertime. So it's really interesting to look at the summers. What's happening during the summers? Are they cooling here in Ohio? Well, what's interesting, the National Climate Assessment, looking at changes in the coldest temperature of the year during winter versus the warmest temperatures during the year in the summertime, and the changes between those. See a lot of red dots here for the wintertime, where our absolute coldest temperature in the winter has warmed 2 to 6 degrees across the country, about 2 to 4 degrees here in Ohio. So it's not as cold. That coldest temperature we get in the winter is not as cold. We get shifts of the growing zone, north and west, because of that. But then in the summertime, you see a lot of blues along the Midwest and points eastward into the Ohio Valley. So our maximum daytime highs, those highest temperatures that we reach in the summer, have cooled on average 2 to 3, 2 to 4 degrees. How is that? Our summer daytime highs. Now our summers are still warming, and they're warming primarily due to overnight temperatures. We just have to look at last year. For instance, Columbus had 12 record high overnight lows, right? So temperatures that stay 77, 78, 80 degrees at night. A couple of things. One, to remember the Dust Bowl era is in the first part of that. What was the Dust Bowl? It was a decade of very dry spring rainfall deficits. Dry air warms up very rapidly, and you get really extreme high temperatures. But as soon as you add moisture to the atmosphere, your daytime highs are limited, right? And a lot of that's been tied to agricultural intensification. We've got a lot of crops, a lot of green, pulling up moisture from the surface, transpiring that through the leaves, evaporating into the atmosphere. And that water vapor then keeps your overnight lows warmer and your daytime highs cooler during the summer. Then we can flip to precip, and I really think this is, when you get down to it, it's the face here of Ohio. Annual precipitation changes across that period for the U.S. is about 4%. In Ohio, again, it's 5 to 15%. And a lot of that's been driven by fall trends, but also springtime. So we have these off-season precipitation trends when we don't have a growing crop. And what's happening during the summer? Well, trends aren't as strong, or they're even flat, and some months are decreasing in precip. So we get seasonal changes in our rainfall, and also the increased intensity, as I'll break down some of that data. So, coming off this spring that we had, I was interested to look at, spring precipitation changes across Ohio. And so what you see here is the average March, April, May, and June precipitation, okay, from 1970 to 2018. So in terms of rainfall frequency for spring, it's up about 3 to 11%, depending on the month. And spring precipitation in Ohio has increased 15 to 17%, an inch and a half to 2 inches since 1970. But it's strongly driven by April changes, okay? Almost 24% increase in the precipitation during April and a little less in May and June, okay? And the intensity of those events, the largest increase, again, is in April. Those rain events of a half inch or 1 inch or more have increased a lot in April. So it's not surprising, and Gary mentioned this, you look at field days suitable for field work from Cheryl Turner and Nass. The blue curve here, this is 1995 to 2018. The blue curve here is the April suitable fieldwork days. The orange is October. We've lost 5 days in April and 5 days in October. So a 10-day longer growing season vanished right here with the 10 days that we've lost in the production cycle, okay? We can look at extreme precipitation. This is how things have changed across the country, looking at these extreme events that pose really serious problems for erosion and water quality risks, increasing greatly. I want to break that down a little bit further, a little bit closer for Ohio. We can look at our annual departure of average temperature back to 1895 Blues are drier than average, the average period being our normal right now, which is 1981 to 2010. The red bars indicate above average, and you see the last decade and a half, warmest on record, wettest on record. NOAA broke down, did some state summaries here looking at extreme precipitation events. Again, these 5-year means since the late 1800s. Events greater than 2 inches. You see almost this stepwise change here, right? Since the mid-1990s in terms of the amount of the heavy rainfall that we're seeing, these extreme events. There are peaks here, 1913, 37, and 59. These are all major flood years in Ohio. So the point of this graph is we're persistently threatened by flood conditions. Does it mean it floods every time? No. What do we do with the water? How do we store the water? How do we move it? Where does it occur? But we're under a persistent flood threat, right? That's the reality of what we're living with. So I took a look at some 21 stations across northern Ohio, and again, some of you have seen this already, but kind of breaking down in thresholds the amount of water coming down in these events. And these are 5-year totals here. So 3 inches, it's kind of flat, it's hard to see a trend. But as soon as you start adding 2 inch and greater, 2.5 inches or greater, 2-inch rainfall events or greater, and 1.5 inches and greater, you see this steep rise, right, in those heavier precipitation events. And these are daily rainfalls, right? We're seeing it too. I don't have data to show you today on things like hourly rainfall rates and 5-minute rainfall rates, which are important for our next speaker who's going to be talking about some of that stuff. But you see the big increases in the intensity here of those rainfall events. So that's what we're seeing, and those are part of what's caused the problems that we're seeing. And we can project in the future, and we have these things, we call it imperfect models, right? We know forecasting and projecting in terms of projections into the future. We're using models that take the best account of the atmosphere we have today, and we think about, okay, are we going to have more or less greenhouse gases in the atmosphere, more carbon dioxide and methane, nitrous oxide, water vapor? Are we going to have more or less? How much of that are we going to have? So it's all coming down to, again, the decisions that we make. But temperatures on average by mid-21st century, some 4 to 5 degrees warmer on average. Most of that, again, probably at winter and during night. Projected changes in average precipitation is about 3 to 5 inches more per year. So Columbus, we had our record last year, a little over 55 inches of rain. That could become more frequent, right? It may not reach 100, but what about our 90-degree days? We certainly see increases both on lower and higher emissions there of 20 to 25 more days. Okay. Nights where we stay above 75, again, changing about 20 to 40 more nights where we stay above 75. What does that do to the crops and the stress? The overnight lows during the winter falling below freezing, about 30 fewer days below freezing. How does that change weed management? How does it change the crops that we select? Insect management. Growing degree days do increase, right? So we see a big increase in that as well, or there's some potentials there. Change in the number of days with above 2-inch rainfall events, it's 65 to 85% increase, right? So what we've seen is a lot of what we project. Warmer nights, warmer winter, more rainfall, more extreme rainfall, more off-season rainfall. That's what we expect. So I've been playing around with this a little bit this spring just for reaction. So what if I told you this is our new normal? It's not that far-fetched to think by mid-21st century that this is our new normal. It may feel extreme now, but the trends are more of the same, right? The longer growing season, winter warmer temperatures during winter and at night, higher humidity, more rainfall, more autumn precip, more intense rainfall events. So we can think about our climate migrating a bit, and I like to show this as well. If we think about Ohio as a 2003 climate here, we're more like southern Illinois by 2030 during the summer, and more like Arkansas or East Texas during 2095. What does farming look like in Ohio with an East Texas or Little Rock, Arkansas climate?
We need to raise rice.
Right? So those are the questions that we're asking. I think these are good questions to ask. The impacts. You guys have felt the impacts. We talked about it. Stress on humans and livestock, stress on those that are working, increased need for adequate cooling with livestock as well, pollination, grain, fiber fill, things like that. I mentioned shifting growing zones, weed pressure, insect pressure, potential diseases. The variability switches, still these big polar outbreaks in the winter. Think about precipitation impacts. It's all along the gradient, right? It's not just the urban or rural, it's all of us. Increased risk to damage of infrastructure and health and transportation-related issues. Intensity does mean more runoff and potential contamination, non-point source pollution, right? And you saw this figure. This was provided by Sam Custer, but it was out in Darke County, 5.5 inches of rain in 2 hours. Right? How do we build resilience to that? I'm not sure there's an answer to that, right? How 5.5 inches of rain in 2 hours. But we know these types of events are increasing, where we're flooding major thoroughfares. Just a few weeks ago, on the south side of Columbus, 665 and 71, I sat for 2 hours with 4 or 5 feet of water on 71, right? It's not just an isolated event. They're happening more frequently. And we had this friendly conversation going on with nutrient flow and harmful algal blooms and such. Right? When you've got that much water coming down the Maumee River, that conversation's not going away, and there's important things to think about. Other concerns, shifting precipitation patterns causing things to bloom earlier or off target. Invasive non-native plants and animals expanding. The connections between pollinators, right? Birds, insects, and other things when we have these seasonal shifts in precipitation. We can think impacts of soil processes, increasing temperature and those impacts, potential loss of soil organic matter, certainly increasing rainfall puts enhanced surface of runoff and erosion in perspective, nutrient leaching, things like that we need to think about. So, a lot of the conversation is turned, and you hear these things called non-regret decisions, right, where you have mutual benefits. And there's a big push to think about soil and water quality here in Ohio. And I think it's a good opportunity where, the drivers from our changing climate really overlap with the need to improve the quality of our soils and our water. Because the healthy soils are impacted by this, right, with erosion and compaction, loss of organic matter. So if you think about things about, tillage intensity and crop selection, and there's a number of decisions that can be made regarding these, from conservation and controlled water structures and things like that, and some of those topics that our next speaker is also going to hit on. A lot of conservation practices and a lot of decisions and discussion going on. What strategies, what strategies should I use? How do I slow the water down? How do I improve the quality of the soil and the structure of the soil? Those have mutual benefits to what's happening. Other crop and water management strategies as well. I think about all that water. How do we store the water for use during seasonal water shortages? We see our jet streams shifting a little bit north here, right? During the summertime. That could mean drier summers, even though we're getting these wetter springs and fall. So is there a way to take that water, that excess water we see? Maybe it's an innovation. Maybe it's more ponds. I don't know. These are the types of conversations I think are good to think about. And then obviously the impact on mitigation. And when we get to the panel, and Fred Yoder will probably speak a little bit more about climate smart, this idea of climate smart, but ag being part of the solution here. Soils being part of that solution. Ratan Lal, distinguished professor at the university, talks a lot about that potential of soil to sequester the carbon. 10% of our current emissions are possible in the soil through things like cropland management, cover crops, things like that, concentrate, pulling down CO2 and that potential, right? And again, we want to be able to provide a lot of information or resources. And one great place, and hopefully you got the flyer out front, is with the USDA Midwest Climate Hub, which really serves as a hub of information across the region. There's a lot of resources in there. I picked one. This is the Adaptation Resources for Agriculture. It's a pretty substantive, pretty large volume of information, but it's certainly readable at leisure, really looking at strategies for adaptation and things that I think are important to remember. And there's 8 strategies up here that you can see, and I can highlight some. So I mentioned, fundamental functions of soil and water. Really building the resilience. I like the term sustainability and resilience, but resilience makes me think of we're having to adapt to changes. versus just keeping things status quo, right? So we're learning together in this process. Reducing existing stressors on crops and livestock is another strategy. How do we reduce the risks from warmer or drier conditions depending on where you are, right? The longer term impacts, from extreme weather. It's hard to determine these. When we think about extreme weather, a lot of us think high windstorms, tornadoes, and trying to think about how those are changing across the region can be a little bit difficult because they're small scale. A lot of them go undetected, right? Versus these larger changes in precipitation and such. But there are a lot of good tidbits in there and a lot of good information that you can pick up on. And I encourage you to, if you get an opportunity, to look at those resources that are available. So with that, I'll go ahead and conclude my talk, and we'll have plenty of time for discussion. Again, if you wanted to check out the slido.com, we'll be pulling that up as well. And just, a lot of us, when we talk about our changing climate, we like to remember a few things. One, that it is real, right? It is real. We're living it. Two, that we are part of the cause of what's happening. So humans are the cause. Three, it is bad. It has a lot of detrimental effects. But the last one's really important, is that there's hope and that we can do it. And I think ag can lead the country as an example, and lead other parts of the world in how agriculture can transform and think about both adaptation and mitigation to these changes. So thank you for your time.